All right, students, we're here. I'm outside sitting on my deck with my two dogs on this beautiful Monday, almost afternoon. I'm going to take you guys through the 6.4 notes. So really this is kind of just the setup. All right, we're just going to talk about some generic theorems, some stuff you guys could probably already figure out on your own. And this is more laying the foundation. This is like the basement, and then 6.5 we're going to apply these theorems to story problems. And usually we do a cool fun activity with mirrors and we go into the gym and measure heights of things indirectly, but unfortunately we won't have that opportunity. All right, so let's just dive into it. This follows the iBook too. A lot of these problems, if you just want to work through the iBook, you don't necessarily have to listen to my beautiful voice. If a line parallel to one side of the triangle intersects the two other sides, then it divides those sides proportionally. All right, so this is saying we have XY and DF. These two sides are parallel, and XY specifically is intersecting both sides. All right, then we have this true proportion, EX over XD equals EY over YF. And the converse of this is true as well. If that's a true proportion, then those lines must be parallel. Now again, this kind of seems abstract. Why do I need to know this? Again, this is just the foundation, and tomorrow's section we will dive deeper into it. So let's just start doing some examples. All right, it's telling you this side is parallel to that side. Find the length of MR. All right, rather than call it R, I'm just going to call it X. Well, since those lines are parallel, X over 12. So it's basically top left over bottom left equals top right over bottom right. So you see how that corresponding parts match up? And again, the way the problem's situated, it's like the fraction is almost already written for us. All right, just match up the corresponding parts. That's the most important thing. From here, it's just a matter of cross multiplying and solving. If you want, you can simplify this to 3 over 4. I like to simplify first. It's easier to do in your head. If you just cross multiply and you're good at using a calculator, it might be easier that way. Either way, you get X equals 9. Sweet. All right, now we got the famous shoe rack problem. Kids come back to me year after year telling me about how the shoe rack problem's their favorite problem. It changed the way they perceive the universe. All right, let's get into this life-changing problem. AB is 33. BC is 27. CD is 44. And DE is 25. So we have a shoe rack. You can see this shelf part of the shoe rack divides this triangle into these measurements. Explain why the gray shelf is not parallel to the floor. If it is parallel, so this is like proof by contradiction. You're going to prove that it doesn't work. So it can't be true. 27 over 33. If it was parallel, this would be true. 27 over 33 equals 44 over 25. Now these are some bizarre fractions. All right, we got 27 over 33 is 0.82. 44 over 25 is 1.76. Those don't equal each other. That's why. All right, explain. I just like to use math. We set up a true proportion that didn't work, so it ended up being false. So it's impossible for it to be parallel. So those shoes aren't parallel. And looking at these shoes, these are some Jordans. There's the Jumpman right there. These are some Nikes. Whoever has this, whoever closet this is, man, they got us some nice shoes. All right. Now we got some iBook examples. Is DC parallel to CB? Again, you can just work straight through the iBook, tap the images, read, do whatever you want, or you can listen to me. Again, the fractions are basically already made. Nice. 18 over 6. One way, there's several ways. What I would do is I just simplify and realize these are both 3 equals 3, that's true. Sometimes students like to cross multiply and see if it works out. All right, if you cross multiply, you're going to get 144 equals 144. And since it's true, Either case is true, 3 equals 3 or 144 equals 144. Thus, using the theorem we talked about at the beginning of the video, these lines must be parallel. The answer is yes. Okay. New theorem. Again, this is just really setting up the foundation. This is like the basement, and on top of this basement, we're going to build a mansion. If a ray bisects an angle of a triangle, then it divides the opposite side into segments that are proportional to the length of the other two sides. So again, this seems kind of quirky. Who really cares? All right. This ray makes those two congruent angles. So it's saying BC, so it's saying this side over BA is equal to CD over DA. So you can see how they're using the right over left on the top and right over left on the bottom. Again, it's just setting up the corresponding parts. So again, if you have the ability just to say, well, we have 9 and 21. Those correspond. I'm going to do right over left on the top. Over here, I got X on the right, 14 on the left. So however you want to see it, equals that. That's one of a few proportions you could set up. Cross multiply, you're going to get 9 times 14 is 126 equals 21x. Divide both sides by 21. X equals 6. Nice. We're cruising right along. You guys are doing really, really pretty okay. All right, so we see we have an angle bisector. So we got to determine the value of X. So I'm going to look at this top stuff. I got the left over right. 5 over 4x plus 1. Then on this bottom, I got left over right. 3 over 15. Again, setting up this proportion, that's the hard part. If you can get this far, it really just becomes a massive algebra problem. You're going to get 5 times 15 equals 3 times 4x plus 1. All right, what's 5 times 15? It's going to be 75. And then we got 12x plus 3. So then we're going to subtract 3 from both sides. And we're going to get 72 equals 12x divide by 12, and we got x equals 6 again. 6 seems to be a popular answer right now. Sweet. All right. In these next few videos, we'll work through these problems that go from the iBook as well. Again, you can watch my videos, or you can just work through the iBook. I think many of you guys can just figure this stuff out on your own. All right.